Hello friends, welcome back to my YouTube channel Python Ponder. My name is Girish Kumar and I hope you all are doing well. So friends, from last session onwards we have started discussing about NumPy, one of the library used in Python language. So from this video onwards we will start discussing about NumPy in details. So in NumPy we use two terms ndarray and dtype. So what is the meaning of ndarray and what is the meaning of dtype, we will try to understand in this video. And in last we will understand two more functions, two more parameters, shape and strides. So what are the use of shape and strides, we will discuss in this video. So please watch till the end. And I will request from everyone, if you have not subscribed my YouTube channel, please subscribe it. So friends, let's start the discussion. So first we need to understand what is ndarray. So ndarray stands for n-dimensional array, continuous memory blocks. Okay, so n-dimensional array you understood in last video. Also we'll discuss one-dimensional, two-dimensional, three-dimensional, and more. So data can be handled in multiple dimensions. Okay, so that is n-dimensional array. Okay, continuous memory blocks are what? So for example, we are creating an array for five items, five different items, 1, 2, 3, 4, 5. Okay, so what happens? System allocate address to each number. One has been assigned to a different address, two has been assigned to a different address, three to different, four to different, five to different. So each number, whatever you use in the system, in list or tuple, so each number has been assigned to an address. So address has been given to each number. So what happens in case of list? For example, you take same five items. In case of ndarray, NumPy, you take same five items. So what will be the difference? So here example, I have created one example, 1, 2, 3, 4, 5. Five numbers has been allocated to different locations, different address. So for example, what is the address of one? Address of one is 1004. This is just for example. System will allocate a different address, but just to make you understand, for example, for one address is 1004. So for two, what will be the address? It will be 1008. For three, it will be 1012. In case of four, so system is assigning address beside each other. Okay, beside one there is two, beside two there is three, four, five respectively. Okay, so all items are assigned at same type of address. Okay, besides each other. Okay, if you use same type of items in list, so list will assign randomly. List will not assign besides each other, it will assign randomly. Okay, so let's give an example to you. Okay, so for example here, address of items in list में क्या होता है, what will happen in the list? Okay, so let me correct it, this is not corrected. So it's 3, it's 4, and it's 5. So we have 5 items for list, also 5 items for NumPy array also. So in list what happens? In list address will be allocated like that, 1397808508104. So in last two digits, if you will observe, 04. Okay, 2 is at 36. Now 368. Now 200. Now 232. So what happens? System is allocating memories, different memories and different addresses. Okay, now what will happen in NumPy? NumPy address will be last two digits 28. Now 32. Now 36, 40 and 4. So each number is taking 4 bytes. Okay, 4 bytes mean 28 plus 4, 32. Okay, 2 is also taking 4 bytes, 32 plus 4, 36. 3 is also taking 4 bytes, 36 plus 4, 40, and 40 plus 4, 44. So this is happening in NumPy array. What is happening? System is assigning same memory blocks to each item, and each item, address of each item is beside each other. Okay, that is not randomly distributed like list. Okay, so this is the difference between list and NumPy array. So how NumPy works? NumPy works like this. So each item will be allocated to address but beside each other. Okay, so it improves the performance. So to calculate something, to perform some calculations or computations in mathematical terminology, so NumPy is fast as compared to list, because all items will be stored beside each other. So for system it's easy to fetch any item quickly. Okay, so otherwise system will have to look one by one in each address, right? So randomly address has been distributed, so for that system it's hard to fetch the values. In case of NumPy it's easy to fetch the values because all items are besides each other. Okay, so this is the difference how ndarray works. Okay, so now let's understand the bit and byte concept first. Okay, so for example, this one is not required to understand now. Okay, so now let's understand int 32. Int 32 is one of the D type. D type is also we are discussing in this video. So D types are what? D types are the data types that ndarray, NumPy arrays are getting used. Okay, so arrays are using different D types. So in integer we have different D types itself. Integer 32, integer 64, integer 16, integer 8. So integer 32 means what? You know, 1 byte is equal to 8 bits. You understand, right? That means 32 bytes means, okay, 4 bytes. 32 bits means 4 bytes. So 4 bytes are equal to 32 bits. So int 32 is using 4 bytes, right? Because 1 byte is equal to 8 bit. So int 32 is using 4 bytes. That's why system is assigning 4 bytes to each: 28, 32, 36, because it's using int 32 data type, that is D type, used in NumPy library. Okay, so that is the introduction of byte and bits. Okay, so let's understand details in D type. What are the D types? So we have four mainly D types. For boolean we use true and false. Integer I told you, int 8, int 16, int 32, int 64. So what happens? Int 16 can store integers from negative 32768 to positive 32767. If you want to store 32768, you cannot use int 16. You need to use int 32 for that, because that is greater than 32767. So you need to use int 32 data type, D type. Okay, D type int 32 can store from negative this number to positive this number. Same way int 64 can store a long range, so up to this number. In same way float work, complex work. Okay, so let's understand first. I will explain one. Okay, and complex and float you can do from your end. So here I'm taking one variable dt1 np.dtype. This is the function created for NumPy library. Age is a parameter we are taking. We can take anything. np.int32. This is dtype exactly. In line number 2, this is dtype. np NumPy int 32. This is we are taking. Okay, in 32, int 64 we can take anything. So int 32 we are taking. That means 10,000 can be stored. Let's take int 16. Okay, so now let's take int 16. So run it. See, it's giving error. Python integer 32768 out of bounds for int 16. That means we need to increase the size of our D type. D type is int 16, so that's why it's not getting stored for 32768. Okay, so let's increase it to 32. Now it will store. So now it fetched the values. You understood, right? Int 32 can be used for different range of numbers. Okay, so for big numbers. Same testing you can do for here also for complex and float. Okay, so for complex and float also you have a specific range. Okay, so this is the D type we use: complex, float, int, and boolean. For float we have float 16, float 32, float 64. For complex we have 64 and 128. Okay, so this is the D type we use in NumPy library. I hope you understood meaning of ndarray also, n-dimensional array, and the difference how list and n-dimensional array are different. NumPy is different. Okay, so let's discuss about now shape and strides. So there are two different functions we use: shapes and strides. Okay, shape and strides. Okay, so shape is used for what? Which type of matrix is being used in array? That is given by shape. So let's write a code. Let's remove it. Now let's take a variable x, np.array. So inside array we are taking a list. Okay, 1 2 3. So only 3 items are there. Okay, so let's print x first. Now shape is what it give, what type of matrix it is. Okay, so print x dot shape. So it will give 3 because 3 items are there. Definitely it will give 3. Matrix is singular matrix, right? So it's not 2 by 3, 3 by 2. Let's take one more item here: 4 5 6. Now we will have to enclose it into square brackets. Okay, now print shape. Okay, so now it was 3, now it will be 3 by 2, 2 by 3, sorry, because 2 items are there. This is one item, 1 2 3. this is one item. So two items are there. In each item there are three items. So in each item, inside the item, so one, two, three, this is one of the item. Okay, this one highlighted one is one of the item. In this item there are three items, three. Okay, so we have two items in the list, but in each item we have three. So this is matrix of 2 by 3. Okay, if you increase one more here, 7, 8, 9, so it will be 3 by 3 now, because we have three items and in each item we have three. Okay, if you increase one more item here, so let's increase 4. Okay, so 4, 5, 6, 7, 5, 6, 7, 8. Let's take four different items. Say 2 by 4, that means we have one item plus two items. In each item there are four items. This matrix is 2 by 4. Okay, so this is the actually a shape can return this value, shape function. Now let's discuss strides. Okay, what strides will return? Each item is taking 8 bits, right? One byte is equal to 8 bits. Okay, and there are four items. Okay, so 4 8s are 32. That means one item is taking 32 bits. Okay, because one item is taking 8 bits. Okay, there are four items, so four items will take 32 bits. Okay, so that will be written by strides function. X dot strides. What I told, one item is taking 8 bits, so there are four items in each item. Okay, so 4 8s are 32, so 32 bits will be used for one item. Okay, so it will give 32 by 8. So it will give 32 by 8. Okay, if you increase one more, if you decrease this, okay, let's decrease now. Okay, so this matrix is taking what, three items, 3 8s are 24, so 24 items, 24 bits. Okay, so let's take it 24. So in this way strides and shape both works. Okay, so I hope you understood four things: dtype, ndarray, shape, and strides. So if you like the video, please like and comment and share if possible. So thank you very much guys for watching.